This is the user graphic interface of ICM CFD, which is actually meant for developing the geometry as well as the mesh. So this is a user interface, have this drop down menu, and then there are tools for geometry, meshing, blocking. This is a model there. Once we develop the model, that detail of the model would be available here. And this is ICM CFD 16.0, that is actually the log sheet here. And this is a triad which we can do for any shape for three-dimensional from z-axis. If you view it from z-axis, it looks like this. So what we do is here start with this developing, let's say I want to create a point. So I have different options for creating a point. Let's say I choose this option for explicit coordinate system. So let's say my coordinate systems are at origin, all the values x, y, z, 0. So I just apply it. So I will be able to see that point, and in this model tree you can see the geometry is available, that the point is available. You just toggle it on and off, you can see the points here. If you just right click on this point, you can see the point name here. If point name is 00 here, default name, or if you want to see something about the point info, so that you just select the point and you have a point info that their location is origin. So all this thing you can do it, and if you don't want to see the point name, just toggle off that thing. So that is the point it has generated. And let's say if I want to create another point, let's say from x units, 10 units to the right, so I will be able to create that point. So once I just click on that window, key window, I will be able to these 2 points. So these 2 points are visible now. If I want to see it in 3 dimensions, so I can see that these 2 points are available. If I want to measure the distance between the 2 points, just click on that, select this point and select this point. So you will be able to know the distance. The distance between these 2 points is, and on the log sheet you can see the distance is 10 units from this point to this point. Another way of creating a point is, for example, if you create a point from base point and difference. For example, I just select my base point origin and I want the y distance to be, let's say, 2 units. So I just okay, I have to select first this point and then 2 units. So I have another point 2 units above that point at the origin, and if I want another point y units 2 units up to that, so I got these 4 points. So this is how I have these 4 points I have generated. If I want to see from the z-axis, I can see these 4 points. If I have to create a line, I just go to the line button here and just pick that from points, and now I need to select these 2 points to get a line. If I want to make another line, just by joining it, make it another line, or if you join this, make another line. If join these 2 points to make another line. So we can see that these 4 points have been joined together to form okay. So these are the 2 things. That now you have curves, which are 4 curves, and you have 4 points. So if you want to make it a surface, just go to the creating a surface. So just click on that. So I am creating surface, simple surfaces, let's say from 2 to 4 curves I wanted. So I just select curves, first curve, second curve, third curve, fourth curve. So you need to be consistent about selecting curves. If you are going in anti-clockwise, select all the curves in anti-clockwise. If you want to go to clockwise, select all the curves. So you cannot select first curve and then this curve. You should be following certain order, and then by the mouse shift button you can create, okay, that surface is, you can see on the model tree, the surface is generated. So you don't see that surface if you just click on solid and wire. So you can see that surface on the solid and wire. This surface is created. So by joining these 2 surfaces, you have created that. If you want to have a volume, so you need to create, let's say what I can do is I can select transform using this transformation tool, and here I can select everything what is here visible is my geometry, and I want to make it a copy. And let's say in Z direction I offset it to 0.5 units to the Z direction. So it means this whole thing has been generated, just copied 0.5 units in the Z direction, and we can see that these distances between these 2 points would be 0.5 units. So that is what the distance in the Z direction. So I got these two surfaces, just transform those surfaces. So all those rotation, mirroring, and all these transformations you can do by this way. Okay, now let's I make it another this volume just by creating it. Let's say joining the points to get another surface. So right now I just forget about surfaces, joining these points to get curves. Let's say I join these 2 points to get curves and these 2 points to get curves. So I got all those curves. So from these curves I can make it the surfaces by just joining these curves to make that top surface. And let's say this surface to be created. So that's not visible here, because once I show it, then it is visible. And then you see that bottom surfaces are not created, just forget about right now. So we have to create the bottom surface as well. So just by joining these four curves to make that surface too. And let's see how many surfaces we have. Okay, still this surface is not there, and only surface now I have to create is this. So just forget about surfaces. Go once again selecting that 4 curves, 1, 2, 3 and 4. I will be able to join those all the okay, so this part is all created. So all the surfaces have been drawn. We can give certain name to these surfaces. That is much better for us in our problem solving. For example, if I just say create a part, and I just create a part, let's say I want to give a name to that part. Let's say in is the name of that part, capital in. So let's say I want my fluid to move into from this point. So I just created this surface to be made as an in. So I can create a part which is now a different color, and let's say my fluid must go from that. So I just make it an out, another surface that is out. So just by selecting that thing, that would be the out surface. And let's say this thing is my top wall. So I just select the top wall here, not that surface, but I don't need to surface, I need to select the surfaces. So you can toggle the switches here, because you don't want points and curve to be selected, you want surfaces to be selected. So that is the top wall. And then let's say we go into this bottom wall. So just make it a bottom wall here, bottom wall. So just like that, bottom wall. So bottom wall is created. Okay, so now you can see different parts I have generated on the model tree. So just show on the part, in is there, out is there, bottom wall is there, top wall is there. So still I need some geometry. So side walls to be also created. So I just give name to the side wall. Let's say side wall 1. I just select that to be my side wall 1, and the last one is I wanted side wall 2. I just select those side wall 2, so that becomes my side wall 2. Okay, I can give some good colors by just clicking on the part and right mouse click, and you can see this menu. So I say good colors. So all these colors are available. So you can see the bottom wall is there, the top wall is there, the ins and outs are there, the side wall 1 is there, the side wall 2 is there. So all these surfaces have been given a separate name, so that is much better. So this is how we have created a geometry. So there are different ways of creating a geometry. I have just created it from a bottom to up approach by creating points, then creating lines, then creating surfaces, and these surfaces build up together to create a volume. Okay, so these are the ways. For example, here the body is created. within that volume, what the body is, that body can be created. Okay, now first step is completed. Now we want to have we have given names as well. Okay, one more thing which is always feasible to do is just having a geometry, and you can see all the points are there. Okay, right now it is of different colors. What I do is I now go to the repair the geometry, and with this default setting I just say repair. So I can see that all entities have been repaired. If there is a problem in the geometry, that is rectified, and now see you can see different colors which have different meanings. So this is what my parts looks like. They are bold red color. These are my geometries actually. So if I just want to see the geometry, I can give my own name to the geometry as well, just creating a part. Let's say I just create a part geometry, and here this geometry is all my points, and so I have to select the entities. For example, I want to select points as well as curve, but I don't want surfaces to be selected. So whatever is here, that becomes my geometry. So I can see that, okay, now it is all my control. What is geometry is? Geometry is just points and curves, and which are visible here because no surface is associated with that geometry part. So this is just giving a name, and these names would be appear as a boundary condition later in our problem. So what I do now is to create a mesh. I'm using this blocking approach. I go to the blocking toolbar and create a block. Once I create a block, want me to give what my name for that block. Let's say name fluid is my block, and I use this project vertices and orient with geometry and select all the entities in the geometry. So I have created a block oriented with that geometry. And how do you see? You see that there is another geometry toolbar, and there is a part toolbar, and there is a blocking toolbar. And if you forget about surfaces and points and curves, so you see no points and curves and surfaces, but still there is a blocking is there. So these are the edges of the block, and these are the faces of the block. If you want to see the faces, these are the faces of the block, and if you want to see the block, so just make it a solid block. So you can see that some block is created within that geometry, that is green in color shown here, and you see that pre-mesh parameter has already developed here. So I have oriented the geometry with respect to that block. This blocking is a very useful approach, and it has its own topology. You don't need to go into the beginning for all that, but just what I do next is to associate my curves with that edges. That is actually a part of the block. So one thing I can do is I can do the association from this button too, but what I'm doing now, directly creating a mesh by pre-mesh parameters. I go to the pre-mesh parameters, and here on that pre-mesh parameter I select my edge, so edge parameters, and now let's say I select my edge. So I forget about curves. Let's say this is my edge, and right now its length is 10 units, and it has 2 nodes. Let's say I want 21 nodes here, and all these nodes to be linearly related. Just I select a uniform, and what I do is one more thing, I copy parameters to all parallel edges. So all parallel edges have 21 nodes here. So I just apply it, and then I select another edge, this vertical edge, and it has distribution like let's say it has 11 nodes. So these 11 to be applied parallel to that, copying the parameters to parallel edges and apply that. So you have 11 edges, so all these things. Okay, now you are in a good position to make the pre-mesh. Just click on the pre-mesh and just say yes. So you can see the mesh is generated, 21 nodes here, 11 nodes here, and two nodes is only on this side. So I can select one more time the number of edges. Let's say I want on this edge as well. So instead of 2, let's say I want 5 here. So I just click on 5 and go again for pre-mesh. So now I can see the okay, you just see the solid wire of the mesh. So this is, you see the 4 meshes in that direction too, And so this is the mesh I have created, and 21 nodes here, 11 nodes here. So my meshing part is by means of blocking is so easy if I do in this manner. So this is actually the blocking part. So I have developed a mesh, and this mesh is quite in my control. For example, if I want certain other law on that edge parameters, for example, let's say here, I want certain law, and law can be done with different ways. Let's say I want it from graph. So 11 nodes here, but I want certain functions, let's say some exponential functions. So, and just reverse it about x. So let's say the some nodes are closer at that edge, and I just done like this. So I will be able to see the distribution here by just clicking on the edge parameter. I just click on that and just make it. So now you can see, okay, so you have more closer nodes here. Okay, I again can go back. Let's say if I want it from the wall, so I just select one more times the law, that is actually from graph. You have from graph, and here I just reverse it about x. And let's say if I want something closer here, some more nodes here, and some higher nodes here, and some, let's say, some distribution I can just pick up by my own. So that sort of a distribution, I just make it done, and then apply, and just go to the pre-mesh. I will be able to draw the mesh. So the number of nodes are closer at the wall and less at the center. So this is how you can create the number of nodes and the shape of the nodes. Now you have some more closer nodes capturing the boundary layer close to the wall from the top wall. So this is how I can create my mesh parameter. So this is what the mesh is looks like. And you can see all these things to be stored somewhere. Actually, I have missed it in the beginning. First thing, I have to change the working directory where the files are. For example, I just want it on my D drive. Let's say I have a course ME314, let's say online course, and I'm doing some CFD part, and I want some CFX part. These are the folders I have already created in my working directory. So I just make that my working directory. So my working directory, all my files would be available in that. So if I want to see, okay, what files are in ICM-CFD, so right now it is empty because I haven't saved the project. So what I do is now I go to save the project. So once I save the project, let's say I just call it project 1. So once I save it, and I go to that folder, I can see different files have been generated. So this project, different project files have been generated on that, and one of the file is TIN file. TIN file is actually the geometric file. PRG is the project file. So the blocking I have used, the information about the blocking is that, and the boundary conditions, what I have made is I can do the boundary conditions to here. So this mesh is actually created, and let's say if I want my mesh to be formally applicable for the software, I can go on the right clicking and convert to unstructured mesh. Then you can see another thing can come on this. You have a blocking, and now you have a mesh, and these mesh have shells and volumes. So this is different from pre-mesh. So here you have a pre-mesh, but it is different from pre-mesh. So you can see the solid and wire case. So this is actually a different mesh which has become so for the solver it is actually the unstructured mesh, and only thing happen is the hexa file is generated for that, which is UNS stands for unstructured mesh. So you need to look into the different files that is actually being generated in this software. Okay, so I mean no need to worry about initially. So it is something I can go to an output. Once I go to an output and I can select a solver, let's say ANSYS CFX is my solver. I can have a provision of Fluent, and there's so many solvers available. So let's say my solver is ANSYS CFX. I just apply it, and if I want to see the boundary conditions, because I have given particular names to that surfaces. For example, on this two-sided surfaces, I have given different names. So these names becomes my boundary conditions. So I will be able to look on different bound. Let's say I go to the volume, and then one side is fluid. Okay, so right now it does not show any boundary. I just accept it. Let's say once I accept it, what happens is I can see the boundary conditions, names of those, okay, fluid, and I can create different parts, but I think here it is right now, everything is default. Okay, right now it is not just set, but I'm sure that that would be available. I just accept it as my boundary conditions, because here all the parts have been given certain names. Okay, so now if I just want to see it in ANSYS CFX, I just need to put write the input file for the available, which is that file will be available for software to read. I just save the project. Here project 1, this default setting is done, and I will be successful enough to calculate this .cfx5 file for project 1 is created. So this is how we can do the geometry, and we can do the meshing. So and I will see how in the next lecture how we can do it in CFX5. But there are different ways, let's say, of making geometry. There are some easier ways, like for example, if I just close that project, so I just close that project and nothing I have, no model I have. So okay, I go to the geometry toolbar, and for example, let's say I want something to be created which will be available for me in this I go to the surfaces instead of point, and I use the other approach called top-down approach. So I want some surfaces, already standard shapes are there. For example, this is a standard shape, and their dimensions to be provided here. For example, its box is an origin, and its size is, let's say, 20 units in X, and let's say I go for 10D, then it would be, or 1.5D. So I go for 25 in the X direction, and on the Y direction I go for 1.5 in the Y direction, and 0.1 for sake of simplicity in the Z direction. So I just apply it. And I can see that geometry here, because it's not curve and parts are not shown. Just click on that. So I will be able to generate a bar of length. This length is 0.1. I can measure the distance. And this, forget about surfaces. I can measure the distance. This is 0.2. It is something, or the distance is. Okay, I don't know what distance they have made. Is 0.1. Actually, it is 0.1. 0.1 is the distance, and this distance is from these 2 points would be, just measure the distance, that is something 1.5. So I will okay, undo. I just make it an undo here. What I've done is something wrong. Undo that. Okay, undo that. So I can measure the distance from this point to this point, that is 1.5. So it is 1.5 units, and the whole length is 25. So I can measure the total length as well. You need to use your mouse intelligently. Just say, let's say I want only curves, and just click on that to. So that is 25 millimeters. So 25 is the length, and 1.5, it means 1.5 centimeter is the radius, let's say, and 25 centimeter is the length, and this Z dimension is not important for us, because we are dealing with the, let's say we are dealing with a two-dimensional problem. So I just make it this two-dimensional problem. Okay, I need to give the same thing. Now I have all the surfaces available. What I do is I give particular name to all these surfaces. So let's say I give a name, create a part. So in one go I have created an object. So I just give one name, let's say in is the name which I have given to that part. So that surface, okay, I want surface to be selected, not points, not curves. So that surface is selected. So that becomes my inlet. And then I go to select my top wall. So top is that, I select the top wall. I select side 1, for example this one. I select the side 1. I select now the side 2. Let's say I just make it side 2. This one is side 2. Okay, so in, out is not done. Okay, so because I have all the created, I have all these parts I've created, I can see that. Okay, so out is here. Okay, out is here, and then I can go into the bottom part, because the bottom is to be selected. Just go into 3 dimension and just turn it away so that I can select the bottom part. Okay, so this is bottom part. I've selected this bottom surface. Okay, now I have everything here. Let's say just forget about curves and surfaces. Let's say if I want to see all the surfaces to be there and all the parts, let's say in is there. I want in to be in that place, and I want out to be there. Out is not created. Okay, out is there, but it is not visible here. Out is visible here. And then side 1, side 2, top, bottom. So all these things have been created. So these are the parts actually I have created for a channel, and I want the fluid to flow into that channel. So let's say I make this as a project, save project. Let's say I give a name, let's say fluid channel, CHAN channel. Fluid channel is my project, and this is I just give different good colors to all the parts, so I know what is in, out, side 1, side 2, bottom, top. So all the parts are there. So if I just want to make sure just there and go to the geometry, and you can see all the curves and points are there. So this becomes my geometry, and no surfaces is there. So all surfaces have been created as a part. Okay, so this is the first part of the project which we want to start as a fluid channel, let's say. And the better is actually, you see there is not a curve here. So what I need is, I mean, probably it's not visible. I just make it a repair of geometry. On the safe side, I do that. So now build topology is completed. So it is now the repair work is automatically done. But for complex geometry, this takes quite a bit of time. Okay, next thing is I have just created all the surfaces with giving good names, and we know all these ins and outs, and have particular names, and this channel is created a long channel which is 25 centimeter length and 1.5 centimeter dia. So 3 centimeter is actually the dia of the channel, which is a very small channel, and in Z dimensions I have just taken 0.1 because I don't need to resolve anything in the Z dimensions, a 2-dimensional problem. So this is what I have created. Okay, so this is my channel I have created. Okay, the next thing I can do is to make it blocking. Just go on the blocking, just take it a fluid as a just a block, and now I can just set the edge parameters. For example, instead of selecting the edge, I don't want to see right now what I don't want to see. I can see that from the surfaces I don't want. Even curves I don't want, I just want edges. So for example, on this edge, I want some law to be followed, and let's say 21 nodes have been taken, and the rule is I just make it a graph actually from the graph, and I just choose a function, let's say exponential function. So I just make it some more closer here, and some smaller number of closer nodes here at the edges. I just make it done. So some closer at the edges and some less closer in the middle. And then I go to that thing. I have around 25 length, so I just make it 100 probably, or 101. Yes, okay, that's 101, looks fine. But I want here the law is uniform, it should be uniform. So I just apply it, so it's distributed 100 nodes uniformly, parallel edges, and all that been selected as a parallel edges. So that is something my default copy parameters to all parallel edges. And then I just click on this pre-mesh toolbar on the blocking. Then my mesh would be generated. So I can see my mesh here, and I can see there are only 2 nodes in the Z direction, and I don't want, let's say, in the solid 10 wire, and I don't want to see my edges, let's say. I don't want to see the surfaces even. So this is something, a mesh I have created. I can see it from Z-axis. So this is the mesh I have created, and it has 21 nodes in the Y direction, but they are almost all uniform actually. So it means I have changed the law here. Okay, so I need to work out, okay, here the setting is much closer, so it means and you see that here as you are approaching, it is not the same law. It means it has not copied parameters to the parallel edges actually. So what I need is go there, forget about pre-mesh. Right now we don't need to bother about the pre-mesh. I just go there and just select edges, and then on edges I just select one more time this edge, and there is a law associated, that is spline curve, and then I copy parameter then and apply. So I want to see 21 nodes here which are closer. Okay, and if I have to select, let's say, this edges, and I want only 2 at a uniform, because I don't want to serve here. So okay, so this is something I applied, probably I didn't have applied it earlier, that's why it's not showing it. Now I just go to the pre-mesh parameters. So now I can see, yeah, here also on the outlet also we have this distribution more closer to the wall and less to the middle. So the same thing I observed here. So this is something, a mesh, I have it throughout the section. I have this mesh, and I can enlarge that too. So this is the 21 nodes here, much closer. This is how I have created, and I just save my project, and I go to the output mesh, select my solver, let's say ANSYS CFX is my solver. I just apply it, select my boundary conditions. Boundary conditions must be known here. Okay, yeah, now I can see this. Bottom is there, out is there, side one and top is there. I'm not able to see in and out, probably there's something happening with this. Okay, in is there, and some fluid is there. So something, I just accept that, and I just go to that place, saving the project. So once I do that, I will be able to generate a .cfx file. Okay, so it's asked me to fluid channel. I have to make first my fluid channel is my project. No, okay. So before, okay, one mistake I have made. Actually, I have just right now the pre-mesh. This is only pre-mesh. What I need is, before saving it as a file, I need to convert this pre-mesh into unstructured mesh, and then okay, do it, because now it has become another meshing toolbar. Mesh toolbar is there. Now I need to select once again boundary conditions. Just go to that and just save the project, and then it won't ask me. So it actually done with translation. So fluid channel.cfx5 is created. So this is I can ask this file to be available on my CFX tool. So this is where I stopped today's lecture. So in this lecture we learned how to build a geometry and how to do the meshing through blocking. Okay.